Alright, in this video we're going to be talking about how to evaluate functions, and to get going, just remember that f of x is just a fancy way to say y. It's nothing special. So if we're referencing f of x, we're referencing just y. So for instance, I could give you the equation y equals 2x plus 3. That's the same thing as saying f of x equals 2x plus 3. So anytime they say like find f of x, they're talking about y. Alright, so keep that in mind. So the first thing I want to hit on is this notation that we were just talking about. So what's inside the parentheses is your input, and what's outside is your output, what comes out once you put that number in. And so you know that ordered pairs, that's an x and a y. Well, input's another way to say x, output's another way to say y. So our input-output pair for this function notation is 2, 3. There's an x value of 2 that was inside, because remember we were talking f of x, so this number inside is our x. And then when we put in the x to whatever function we're talking about, it popped out a y value of 3. And remember, f of x equals y, so this whole thing we're saying is y equals 3. Alright, so the next one will be negative 1, 4. And the next one is 0, 2. So it's just basically input and output. What's your input, what's your output, and you write it as an ordered pair. And then you can go graph all these if you wanted to on a grid. Alright, so to get to the actual algebra, when we're evaluating functions, it's basically looking to see if they gave you an input or they gave you an output. So with all of these, the numbers are inside the parentheses. So with all of these, the x has been replaced because the x is within the parentheses up here. And so remember, x is your input. So I'm putting these numbers inside this function over here for x. So it's going to be 2 parentheses 1 plus 3. Then I'm going to have 2 parentheses 0 plus 3. So we're just plugging in our x value, which is now a number. And going to simplify in just a minute. So this first one, 2 times 1 is 2 plus 3 is 5. So we could write now that f of 1 equals 5. So I put in a 1, I got out a 5. So this is really the ordered pair 1, 5 if you wanted to write it as a point on a graph somewhere. Alright, same thing with this one. 2 times 0 is 0, plus 3 is 3. So this is really f of 0 equals 3, which again we could say is the input of 0, output of 3, and that be a point. Alright, and lastly, this one's 2 times negative 3, which is negative 6, plus 3, which is negative 3. So we can say f of negative 3, when we plugged in a negative 3, it popped out a negative 3. So our point input and output pair would be a negative 3, negative 3. So in this case, we're plugging in for an input because the number they gave us was inside the parentheses, inside input. Alright, same function, but now look what happened. There is no number inside these parentheses. If there is no number inside the parentheses, you were talking about a y value now, because look what they're looking for. They're looking for the x that goes inside that parentheses. Alright, so if they give you the x still inside the parentheses, they're talking about y values, because remember, f of x is just a fancy way to say y. They're telling you y equals 7 on the top one, y equals negative 9. And we know that this is really y up here, if you want to think of that f of x as y. So what they're asking you to do is work backwards here. They want you to plug this 7 in for this whole thing, f of x, not just x. So we're going to say 7 equals 2x plus 3. That's our y. And then you're going to go solve this. So like minus 3 like we've been doing for a while now. 4 equals 2x, so x equals 2 when you divide. So x equals 2. Oh, not x. X equals 2 when f of x is 7. So if we wanted to put this stuff in context, we could say f of 2 now. We just found our x value. F of 2 would give me 7. So my input-output pair would be 2, 7. Alright, likewise down here at the bottom, they want you to plug in negative 9 as your y value to your function and go solve it. So negative 12 equals 2x, so x equals negative 6 when you go divide. So again, to put this in context, we just found the input that goes in this set of parentheses, because we didn't have the x before. Now we know that x is negative 6. when we have a y value of -9. So this would be the input-output of -6, -9. And if we were to go graph this point and this point that we just got, they would lie on this line, y equals 2x plus 3. These are points on the line. So anytime you're evaluating functions, you're finding points that are true for the graph that you would be getting. All right. So just to show you a different representation, when you're asked to fill out an input-output table, which is what this is, remember x is your input and f of x, which is really just y, is your output. So there's your new function. So if they give me an x value of 1 and 0, that's going inside the parentheses. That's what I'm looking for. So that means I'm going to go plug it in for x up here. So we're going to do 2 times 1 plus 1. Well, that's 2 plus 1, which is 3. So if I do that, that's my output, f of x. So basically we're saying f of 1 equals 3. That's where we're getting this point from, 1, 3. If I go plug in my other one, it says 2 times 0 plus 1. Well, that's 1. So this is saying that for an input of 0, I'm getting out a 1. So thus my point on this line would be 0, 1. And notice we can pull these points straight off the table like we've done before. But now down here, they want you to go backwards. They're giving you y values. So they want you to go and plug in the 5 and -3 for this whole f of x for y. Alright, so we're going to say some scratch work over here. We're going to say 5 equals 2x plus 1 and go solve it. So x equals 2, so that's my x value. So now we just found our input that goes inside this set of parentheses because we didn't have it before. There was no x. They only gave me f of x. But we knew the output was going to be 5. So our input-output point now is 2, 5. Alright, and the same thing for -3. We're going to plug that in for y and go solve for x. So -1, -1. -4 equals 2x, so x equals -2. So now we just found the input that goes with this output. So my point would be -2, -3. Alright, and again, you can pull these points straight off your table, but these lie on this line that we have as a function. Alright, you can also do this same idea with graphs of functions. So I just called this one randomly f of x. I made this one up, but it's just a random function. Passed the vertical line test, so we're good. So if I want to go find f of 0 or f of -6 or f of 4, these are all x values because they are inside the parentheses. We've replaced the x that was there with a number. So that says go look where x is 0, which is on this horizontal line. Alright, so if x is 0, we want to go find where y is. So if x is 0, y is going to be -2. So we're at an x value of 0, y value -2. Alright, now this one says go to where x value of -6 is, which is right here. And we're going to go down and see where our point is. And it's at a y value of -3. So f of -6 equals -3. The next one says go to where x is 4. Well, here he is. He's on the axis. So if x is 4, y is 0. We haven't moved anywhere, up or down. Now these next two, or 3, are going backwards. So this says where does y equal 3? Well, we're going to go up here to where y is 3. There it is on your y-axis. And go find where that function crosses, which is right here at an x value of, I believe that's 7. 1, 2, 3, 4, 5, 6, 7. Yep. So an x value of 7 when y is 3. The next one says go to where y is -7. Well, look at your axis, go down to where y is -7. If you follow it over, you've got this point for sure, but you also have this point, and you also have this point. So you actually have 3 values that you could put here. So we're going to have to estimate on 2 of them. We know that one is for sure -8. And let's say this next one is close enough to -4. Let's call it -4. And maybe we call that one -1.5. So there's 3 that I've circled where we cross. So you can cross more than once. All right, and then it says what does x equal when y is 0? Well, y is 0 back here at the origin again. And if you go over, there's your x value of 4. All right, so you're just looking to see where this function crosses these values it gives you. So here's your practice. Pause the video for a minute, take a moment to write this out, just sketch it somewhere, and then unpause it to check your work. Alright, there's your answers. So on the left-hand side, all I did was plug in 0, -2, and 4 for my x, because these are all input values. So all of these got plugged in here for x. Down here, these are y values, so they got plugged in for f of x for this whole side and worked backwards. Alright, and then we just went over how to do the graph thing. You're going to go look where x is 0. Well, here's x of 0 and the y value is 1. And then you're going to go look where x is 5. Well, there's where x is 5. Go down to see where that point is. It's -4. And then the final one says what is the x when y is 4? Where you're going to go up to where y is 4 and go trace over to your function, which is at -6. Alright, so until next time, keep practicing.